All right, let's get started. Let me get the lights and whatnot adjusted and talk a little bit about the announcements. It'll be relatively short, and then we'll get into the meat of the topic for today. So you all saw the emails over the past couple days in regards to switching over to the new version of the curriculum. There's a form, I guess, that Associate Dean Hanrahan has that you need to sign. You'll have to go see her. Again, my general advice is to switch, but I will also say this. This is your last semester, so we put in that September 1st deadline really for you all, for the folks that are leaving in 3 months, because we needed to have the system in place so that when you all applied for graduation, your degree works was updated in time. You see what I mean? So for the students that aren't graduating for a year or 2 years, that September 1st deadline really, it wasn't really for them, it was for you. But I'll just say this, if you all have any questions in regards to whether or not you should make the switch, or you want to go through and ensure everything's fine with your curriculum, we can take a look at that. You all are really my primary concern in that regards, more than other students who have got time. You all are leaving in 3 or 4 months. Like some other students who are going to be here for 2 years, they got time to make up what they need to make up. Whatever you're taking now, this is it. So if we need to look at anything, just let me know. Okay. Any questions on that? Any quick questions? Okay. So I am going to start using Blackboard a little bit more this semester. I posted the notes for today's lecture, the PowerPoint notes, and the Excel sheet that I'm going to pull up today. I've posted that on Blackboard, so you have that. I also have a YouTube playlist created for the class. I'm not going to record every day. This isn't one of those classes where it's appropriate to record every single lecture. Sometimes I'm not lecturing. Sometimes it's just us coming in and working on your project. So the days where it's appropriate to record, I will. And I put the playlist on Blackboard so you all can link to that. Today is a prime candidate for recording because this is a topic that, you all will obviously need for your senior design project, but I also think this is just a useful concept to understand in general. Like I said before class started, I'm not 100% sure if you've seen this stuff in other classes or not. I don't know how strong you are in this stuff, but I figure this is a useful topic to know, so I figure it's worth discussing. Let me just go ahead and get right into it. So what we're going to talk about today is cost estimation. So the reason why this is so important is because this is going to be ultimately one of the fundamental decision tools that you use for your alternatives in this class, but also just in your career. There's really 2 fundamental parameters of a given project that are going to drive what alternative you choose versus another. One of them is money. The other is time, okay? One project may be more or less expensive, or one alternative may be more or less expensive. Another alternative may be faster or slower to complete. So we'll talk about project scheduling and whatnot as the semester goes on, but I want to delve into some cost estimation as soon as we can, because at some point here in the very near future, you all are going to be evaluating different alternatives for your bridge project. And real quick, you need to have at least a fundamental idea of which one you're going to select based on its cost. So we need to talk about this. So what I'm going to do is I'm going to talk about just cost estimation and cost indexing and things like that in general. Talk about some of the resources that are available. So I brought in 2 cost estimation guides. Also, let me get this sign-in sheet passed around. I've got 2 resources that I've brought. One of them is from 2011, one from 2005. The date won't matter a whole lot once we talk about cost indexing as we go on. What I'm going to do is this. I'm going to put one of them up here. I'm going to put one of them back here with this row. So if you need to scoot up or sit back or whatnot to see this, it's probably a good idea. But it doesn't really matter which one you look at. and that'll make sense as we get into it. Okay, so let's talk about cost estimation, cost indexing. Has anybody ever heard of cost indexing? Do y'all know what I'm talking about? Okay, all right, that's fine. All right, so we'll get into this. So again, one of the most fundamental tasks in any project, especially with civil engineering, I say this about civil engineering, but this is really just any project that you're doing in general, is estimating the cost. And you know, we need to have a detailed breakdown of the different components that go into the cost of a given project. So if we're talking about civil engineering types of situations, we're talking about things like material costs. How much does the steel cost, the rebar, the concrete, the aggregate, the lumber, all of that. Equipment. Do we have any equipment that needs to be purchased? Any equipment that needs to be rented? Any equipment that needs to be maintained? Labor. That's a big deal. That's a big cost that needs to be assessed. And there's labor, there's overhead that goes into that, insurance, workman's comp, you name it, taxes, all that needs to go into it. Engineering, support personnel costs, overhead and operating expenses, indirect costs associated with the project. Profit as well. That's one thing that you all are going to have to factor into your estimate at the end of the day is profit. Treat yourselves like an engineering firm. You're not doing this work for free. At some point, you need to make some money at the end of the day. Okay, so that is the general breakdown of what it is that we're interested in when we perform a cost estimate. Now, by and large, the absolute best resource for a cost estimate when you all get out of here is your firm or your company. Okay, we're going to be using guides like the RS Mean Guide and things like that. And then there's also some data on the West Virginia DOH site that we can use. But I really want to be clear that the absolute best resource is your firm. If you're a firm that does post-tension segmental bridge construction all day, every day, they are going to know how to estimate a project like that better than any of us put together because they do it all day, every day. Okay? West Virginia Paving. I'm sure they can estimate a paving project pretty well because they do it all the time. Okay? I guarantee you we could do all the research and all the data analysis, and in the end they're probably going to come up with a better estimate than we ever would because they do it all the time. Okay? Make sense? But we're you all are students, we're in an academic setting. We need a resource that we can rely on independently. There's a couple of resources that are available. I mean, there's estimation software. There's obviously like catalogs. Like if we were designing, let's say, a building and you needed to determine a cost estimate for the formwork, for the stay-in-place metal formwork for the concrete slabs, well, you could go find the manufacturer and go into their catalog and you could get a cost from there. That's a pretty good resource because they're the ones selling it. Okay? But by and large, one of the most popular estimation guides is what I've given you just now, is the RS Mean Guides. It provides a wealth of information on unit costs for various components, crew productivity, cost indices, and all of that. There is a lot of very vital and good information in a guide like this, and it's really worth checking out. But if you open this book and you take a look at it, it can intimidate you. I mean, you look at any one of the line items and there's just a bunch of crap going on, and you see it and you go, what the heck's going on here? I mean, just open to any one item in the middle of the book and you'll see what I mean. But hopefully after today, us going through some very basic cost estimation examples and going into some breakdown of what's going on, I think you'll find that it's not so bad. So let's get into some basic cost estimation. Arguably, one of the most fundamental equations that you're going to use in cost estimation is the unit price equation. So if you take the unit price and you multiply it by the number of units, that'll give you a cost. So if I got a W10 by 49, that's $60 per LF. What does LF stand for? Linear feet. Okay, so if I got a W10 by 49 and it's $60 per foot and I have 12 feet of it, how much does it cost? 60 times 12, it's $720. That's simple, right? That's straightforward. Hopefully we're good with that. Okay. Now, this is the type of data. So you know, if you've got, let me say this, if you've got your unit cost and you got your number of units, the calculation is pretty simple. This is what RS means lists. So we're going to dig more into this as we look into this. I want to look at a typical line item from RS means. So this is an item looking at concrete masonry units or CMU blocks. We're looking at concrete backup blocks, like we have a 6-inch thick block. Okay, so there's a couple of things that will show up that you may not recognize, like this daily output and labor hours, crew D8, the unit, that should make sense. What is this unit going to be? Square feet, right? So when you see, like, for instance, 198, what it's saying is that this particular unit costs $1.98 per square foot, okay? Now that would be from a materials aspect. This is from a labor aspect. Because we're just talking about block, we really don't need much equipment for that. Certain applications we are going to need equipment, and we'll talk about that as we get in further. Also, you know, we have this total cost. This is just a bare cost. This $7 that you see right here is a total cost that includes overhead and includes profit. We're going to get more, a little bit more detail with some cost estimates later on how exactly can we compute overhead and how exactly can we compute profit. So, so we'll dig into that as we get into it. But so far, so good. Anybody have any questions about this? Yes. That's a good question. Let me pause my answer for now, because when we start looking at the work crews, you'll see equipment costs in there as well. You'll see where that's listed. That's a really good point. It's really just a function of the crews that are listed. So for instance, a carpentry crew is going to have a different set of workers and a different set of equipment required than a steel workers crew. You see what I mean? And with that, you've got the different workers and the different equipment that's needed as well. And you'll see that as we dig in a little bit more. That's a good question, though. That's a really good question. Anything else? This is good stuff. Yes?
So, talk about concrete. This cost is for concrete that is bought from the company like the plant and
Yeah, CMUs, yeah.
not like mixed on site.
You're exactly right. And there would be a different line item for that as well. Just like with steel design, there's different line items for beams than there are for columns, for shapes, for bolts, for welds. With concrete, for columns, for beams, for slabs on grade, all of that. I mean, just start flipping through it and you'll see what I mean. There's line items all over the place. So it's more about just taking your time and digging into it and see what's going on. I believe I gave you all like a heavy construction guide and then just a general construction guide. I think that's what I gave you. Yeah, you've got the building construction cost data, and that's the heavy one, right? That's heavy civil. Okay. So that's going to be a lot on excavation and large concrete placements and things like that. Okay. Everybody good so far? Okay. Now, one thing I will caution you on. So, you know, SF is a pretty typical, simple unit, square feet. But I'm not going to lie, some of these units even I hadn't seen before when I first started looking at this thing. Like, let me see, you know, like if you're doing electrical work, like circuit breakers, CB. Like, I mean, I know that you know, what a circuit breaker is, but I might not, if I'm looking at unit costs, if the unit cost is in CB or something, like, what is that? Like CEFI stands for cement finisher. Like, you know, I wouldn't probably have remembered that. I've got a link here that goes to their website that pulls up all of the abbreviations. It's probably a good thing to have when you're starting to go through the cost estimation, because if you're going through, you know, a particular, let's say concrete thing, you can't quite remember what CY stands for. You go, oh yeah, that's cubic yards, you know. This is a good reference to have. Some of the abbreviations I think are stuff that we can recognize pretty well. LF is linear feet, SF is square feet, and things like that. But if it's something that you don't recognize, this is a good reference to have. Okay. Everybody good? Now let's go back to my fundamental cost estimate. $60 per foot for 12 foot equals $720. Sounds easy, right? There's a little bit more going on, okay? Let me ask a question. How many of you all have traveled to, Huntington's not exactly a big city, so how many of you all have traveled to a big city like New York or Chicago or LA or a place like that? Okay? Now, how much do you think a bottle of Coca-Cola costs here versus how much a bottle of Coca-Cola costs in New York City? It's a little different, right? Or, if you're at a Yankees baseball game, go try and buy a hot dog or a soda, how much are you going to spend? Like, quite a bit, right? Or even better, what happens, you remember you're talking to someone of an older generation. Back in my day, a Coke cost a nickel or something like that. You know what I'm talking about? Okay. What I'm getting into is a concept called cost indexing. Okay. And cost indexing refers to essentially how the value of goods and services can change with respect to time and location. If you've ever heard the term consumer price index, it's essentially a measure of generally how expensive stuff is as time moves on. Again, it goes back to, that whole back in my day, a Coke cost a nickel. Well, nowadays it doesn't because the consumer price index has changed, and essentially things have gotten, the price has inflated over time. So there's many factors that alter or affect a cost index, improvements in technology, inflation, and what have you. So we need to account for that. We need to account for that in two different aspects. One of them is looking at that book. What's the front of that book say on the bottom corner? What's the bottom right corner of that book say? Or, it's not the bottom right. It's bottom right over here. That one's in the middle. What's it say? What year? 2005. And what's that one say? 2011. It's 2017, right? Those costs are going to change. Now, they may not change much. We're only talking about a few years, but we're also talking about projects that can be millions of dollars. That actually matters. The price of a Coca-Cola probably didn't change much between now and 2011, but if you're buying 1 million of them, it kind of does. That actually matters. So, yeah.
So, let's say you're working on a project, and I know that, we were talking, saying something about a bridge crossing or something. If you are calculating costs for, say, 2017, the project's going to last something drastic, like 7 years, 10 years.
Yeah.
How do you correctly guess what it's going to cost?
That's a good question, and it's not easy. There are models and cost indices out there that are projected out a little bit further along. I'll show you, as we get into this, I'll show you a couple ways where you could do that. But again, let's also be clear, we are talking about estimation. You know what I mean? You got to account for the possibility that your estimate may be a little bit off. I'll show you a couple ways where you could do that, okay? Let me get into how cost indexing works, and then I think our discussion will be a little clearer. Okay, so I got your question and then your question on equipment, and I'm going to tackle both of these as we go on. Okay, let's talk about what a cost index is. So specifically, what a cost index is a dimensionless number that essentially will help you relate the cost of goods either from one time to another or from one location to another. We're going to deal with time first because I think it's a little easier to understand. So RS means reports cost indices at the time of publication. I'm going to pull a table up here in a second. So if you want prices at a different time, you have to convert. And it's a lot like a unit conversion. If you have, I was talking about this in one of my other classes the other day. Let me ask you this. If I have 24 inches, how many feet is that? 2. Now, how'd you do that? The simple answer, how did you do that? You divided it by 12. Now, one way of mathematically or numerically, you divided it by 12. But conceptually, that's not what you did. Conceptually, you multiplied it by 1. And that 1 being the fraction, 1 foot on top, 12 inches on the bottom, because 1 foot equals 12 inches. So you're essentially multiplying by 1. You're multiplying by a fraction that is essentially converting units. Make sense? That's essentially what a cost index is doing. When you look up a figure or a cost in this book, it's not in dollars. It's in 2011 dollars. Okay? So to perform the unit conversion, you have to convert 2011 dollars to 2016 dollars. Does that make sense? So that's where cost indexing comes into play. It's a unit conversion, essentially. So let me show you something. This is in the RS Mean Guides and online. I pulled this one online. Let me see where it is in this book. If you go to the very first page of your book, I'm pretty sure it's in that one as well. But if you go to the first page of your book, you will see historical cost indexes. Here it's on page 700. So if you turn to page 700 in this one, so there you go, there's that table. Do you have, if you go to the very first page, do you have a page where it says, on the table of contents, where it says no, right there, whoop, where it says historical cost index? Right there. Go to page 437. Now your table's going to look a little different than this one because your book's a little older. And your tables probably might look a little different than this one because I downloaded this one online, so it might be a little more, this one references 2016, obviously, yeah, so it's going to be a little different. Does everybody kind of see what's going on here? Okay, so the way that this works is if you look at current cost indices, when you buy the manual is obviously going to reference its first cost index based on the current year. So I believe you should have a column in yours that should say something like January 1st, 2011, right? So it'll probably say 100 on there, and then the numbers will start to decrease. So the idea is, well, back in 1967, a Coke cost a nickel. Well, look at the cost index. It's only 11.3 here, whereas in 2016 is 100. Make sense? So you could go backwards and convert costs. What I want to do is move forward. Now, typically these books will reference either from 2016 or 1993. Are you all still, you all have a 1993 column as well? You have a 1993 column? That's also a standard that's posted in these manuals. I believe that's sort of a reference date that RS Means typically uses pretty often. I just use the 2016 value. So for this example in this problem, I'm going to be using the data from to 2016. Like I'm going to convert to 2016. We're technically a little out of date. I should be converting to 2017. I could easily go on to RS Means online and download a new historical cost index to get this a little more accurate. But for now, we'll just assume we're in 2016 right now. So if you notice, I've got a cost index, let's say I have 100 here, and then in 1985, say I've got, what do I have here? I'm looking at this one, 39.9. So let me show you something. So see how I've got 100 and I've got 39.9? What I'm going to do is this. I'm going to go back to this example right here where I have the W10 by 49 was $60 per foot and it was 12 foot. I'm going to assume that $60 per foot, I'm going to assume that cost is from 1985. So the question is, well, if that's how much W10 by 49 costs in 1985, how much does it cost today? Okay. Would you agree that it's going to cost more? Exactly. Now, how much more is it going to cost? Well, I propose it's going to cost 100 over 39.9. So I'm using the 2016 and 2016. Does that make sense? So 100 over 39.9, that's about what, 2.5? Does that make 100 divided by, it's like about 100 divided by 40, so it's like about 2.5. So I propose that this element is going to cost about 2.5 more times more now than it did back in 1985. Does that make sense? Everybody okay with that? Okay. There's one other problem with that. That's going back to the New York City issue. If we buy a soda in New York City, it's going to cost a whole lot more than it does if we buy a city or a soda right here in Huntington, in the city of Huntington. Make sense? Okay. So in addition to historical cost indexing, we need to perform city cost indexing. Now, the way that the data is reported in RS means is essentially collecting cost information from contractors in 30 major U.S. cities. So Atlanta, Georgia, Cincinnati, Dallas, San Antonio, San Diego, Minneapolis, 30 major U.S. cities. So the idea is that the costs that you are querying out of this particular book are regarded as accepted national average costs. So costs sort of in the USA, if that makes any sense. But what I want are costs in Huntington, okay? Now, start turning past your historical cost indexes. Just start turning past it. And look what you see. You should see some tables of city cost indices. Is that in that book as well? Do you have city cost indices? There you go. So you notice you'll see on the top, you'll see states starting to be listed, and then you'll go to cities and cities. And if you look, you will find one for Huntington, all right? Now, let me also say this. This is listing some fairly, I don't want to say major cities, but, I mean, look at West Virginia and how many cities are listed for West Virginia. I mean, you'll probably have to turn quite a bit, but what cities do we have listed for West Virginia? That's all you have? Oh, okay. I think we have a lot more in this one. So you have an older book, so this one's been updated a little bit. Yeah, so you're in Canada. Yeah. Okay, so what cities are listed? There's a few more, right? Yeah. You have Beckley, Bluefield, Buckhannon, Charleston, Clarksburg, Gassaway, Lewisburg, Martinsburg. So there's a few more. If you're not in one of those cities, just find the one that's the closest and try and apply a little bit of conservatism to it. Yes, sir.
If you're just like the design engineer of a bridge or your structure or anything really, do you decide who the supplier is, or is that the contractor?
That's a little bit of a loaded question. It depends on the project delivery. It depends on who's bidding. That's not an easy question to answer. I will say this. For a project like what we're working on, our job in this course is going to be as the consultant. So what we're going to do is the DOH has requested that in our project, the DOH has requested that a bridge be installed in this location. So what we're going to do is design the most economical bridge that we can. But we're not going to directly specify, well, you're going to get your fabrication done by these folks, or your, concrete from these folks, etc. Now, let me also say this. We are in Huntington, West Virginia, and, if, there are options, but it's not New York City. My point being is this. If you're researching this project and you're able to contact a local company or a local construction firm or something like that, and you're able to get some costs from that particular company and you want to use that to help guide your cost estimation, that's absolutely fine. If anything, I encourage it because it will add a little more credibility to your estimate at the end of the day. I mean, if you're able to supplement your work with what's going on in the real world, that's wonderful, okay? Does that make sense?
Yeah, because the only reason I was asking is, we do a cost estimation, but then the contractor could go and do something completely different and get materials from somewhere other than we reference the data from.
That's a good point, and you're bringing up a very, it's not a controversial issue, but it's an issue in the world of civil engineering that happens from time to time, and it's called value engineering. And what value engineering stands for, or VE, if you ever hear anybody say VE, this is what they're talking about. They're talking about a point in the project where the consultant or the state or somebody like that puts a project out to bid, and they say, well, let's live in our scenario, let's take it out, take it a little further out. So it's April 30th, or it's the beginning of May, or not April 30th, it's fall semester, so it's December. You all have finished your design. You all have submitted your final project, good to go, right? Now let's say the state takes your design and puts it out to bid. So contractors look and they see, okay, we got a 120-foot sun bridge, and here's the design that's proposed. If the contractor wants to bid on that project, great, go for it. But the contractor might also say, well, I can build that bridge for cheaper, you know. That's fine, but they have to do a little bit more work. They have to do what's called value engineering. They have to basically submit additional analysis and design calcs that show that there's a simpler way of going about it. On a side note, that's actually a challenge that I personally have encountered in some research-related projects with the DOH is, you know, when you're developing a new technology that has potential economic advantages, hey, that's great. But the first time somebody wants to build it, they want to charge a little bit. So we've been working on getting some bridge projects installed, and that became a little bit of a barrier is if it's a research project and you want the contractor to do it that way so that you can research it, it's like, well, how do you prevent a contractor from coming in and trying to value engineer it? So that happens. There's nothing wrong with it. It just everybody needs to be informed and everybody needs to be on the up and up. But it happens quite a bit, more often than you would think. And I don't know that there's really anything particularly wrong with it. I mean, let me put it like this. If you are, let's say you're designing a building, and I use a building instead of a bridge for this example because buildings tend to have far more complex connections. So let's say you're designing a building. The structural engineer will come in, and a lot of times what structural engineers like to do is they like to design to develop the full capacity of the connection. So you remember from steel design when we did bolted connections and welded connections, and we would say, okay, we got a dead load and we got a live load. We'll design for that connection, right? Well, a lot of times what structural engineers will do, because connections are so damn complicated, is they'll say, well, I'll just design not for some load, but instead I'll design for the gross section yielding or net section fracture capacity of the member. The idea is that if you load that connection, the member will fail before the connection will. And that's the project that ends up going out to bid. Well, then the fabricator comes and looks at it and goes, these connections are huge. And if they're a steel detailer who designs connections all day, every day, they might actually be able to come in and design better connections. Not because they're a better engineer, but because they have a better understanding of their fabrication practices and their preferred methodology for those types of connections. A lot of fab shops are set up and tooled to do particular types of connections. And if they can do those connections cheaper and with more quality assurance, great, do it. There's nothing wrong with that. Again, just make sure everybody's on the up and up, make sure everybody's communicating. There's nothing wrong with that. If anything, in many instances, it's a good thing. So.
Does this manual show transportation costs, like say from fabricator to job site, that kind of thing?
Not really, because, well, that's going to be very site specific, you know.
Yeah.
But there are some other resources, like if we want to talk about locally, like there's DOH resources within the state of West Virginia that might be able to help you with that. And then also, again, a great resource for that is just call a company and see what they say. Just, I mean, tell them you're a student, you know. Hell, if anything, calling and saying you're a student working on a senior design bridge project and you're calling, exactly, it might get you hired, you know. So it's something to consider, okay?
That can change your design, like place, like you can't give a certain length to the project.
Absolutely right. What happens when you do your design and then the precast plant calls you back and says, we got a 14-week backlog, dude. It ain't happening. It's funny how you're picking a steel beam the next day. You're exactly right. Exactly right. I'm glad that we're having these types of discussions because this is stuff that you definitely need to account for, not only in your project, but in the real world. This is great stuff. Yes, sir.
I know this is going to be a really complicated question, but is there some kind of like statistical approach you can take to project data out and find out what time frame would be the best to buy it to avoid inflation? Like say if you notice there's a trend of inflation in the month of June, say buy your steel in May or something beforehand.
That's a good question. Honestly, I don't even know if the producers would be able to answer that question for you, the folks who actually produce the steel. Some of that variability is even beyond them. So.
So I just want, like, if you could set up your like work schedule to have certain parts ready if you can by that time frame to get it at the cheapest price.
It's I'm not sure I'm not sure that, let me put it like this. I'm sure somebody has done research out there and developed some computational model to predict that stuff, but it's probably so damn complicated that some estimator in some contracting office will probably never use it. You see what I mean?
Yeah.
There's a fine line between technical but keeping it simple as well. Does that make sense? I want to go back to a question that Mr. Cruikshanks asked in regards to what if the project lasts 7 or 10 years? Maybe just take this trend and just extend it out and guesstimate, extrapolate out. I'm not saying it'll be accurate. It's not going to be accurate, though. It's an estimate. You see what I'm saying? Yeah, and just drag it out and see what you get, and maybe apply a small factor of safety to it to just see what happens. But at least you're not just guessing. You know what I mean? So yeah. All right, going back to our city cost indexing problem. Does anybody have any other questions? Okay, so going back to our city cost indexing problem, you know, here we have the cost indices for Huntington, West Virginia. Now, this table tends to get a lot more detailed. First off, you can find those at the link that you see there. All the national averages are referenced to 100. I mean, that's sort of the baseline. Everything's 100. So if we look at the one that we're gonna care about for this particular example, remember we're looking at a W10 by 49. We're looking at metals. Okay. So metals, what do we have? We have the material cost index of 97.8. We have the installation cost of 98.2, and then the total of 97.9. So if we wanted to estimate that W10 by 49, remember we said that W10 by 49, if it's $60 a foot and it's 12 feet, it's $720. But that was in 1985, and that was just in America. If we wanted to convert that to 2016 dollars in Huntington, West Virginia, I will say, all right, let's use the time cost index ratio of 100 to 39.9 that we mentioned earlier, and then 100 to 97.8 to convert to Huntington, West Virginia. So I propose that that thing that cost $720 in 1985 in America, in 2016 in Huntington, West Virginia, cost $1,764.81. Does that make sense? I really wanted that to make sense. Now keep in mind, this is an estimate. I'm telling you, we've had students who come in and they make a presentation, their final presentation, they say, all right, this project is going to cost $542,836.14. Are you kidding me? How in the heck can you tell me that you are that accurate? You know what I mean? How can you do that? This is a little image that I actually pulled out of the front of one of these guides, and it basically says, you don't have to follow this verbatim, but it's basically saying keep your context. Like if you've got a project that costs anywhere from $10,000 to $50,000, you should round your estimate to the nearest $100. We're talking about a project that's $20,000, $30,000. You cannot tell me you can estimate that to the penny. You can't do it. It's impossible. But you should be able to estimate it within the nearest $100. If it's a project's over $50,000, I mean, maybe try it within the nearest 500. If we're talking about $1 million projects, maybe the nearest 1,000. Or heck, maybe if it's that big, maybe even the nearest 10,000. Okay? It's all about just keeping your estimate relative, making sure that you can back it up. Okay? Does that make sense? Everybody okay with that? All right. What I want to do for the rest is I want to show you a little bit more of a detailed cost estimate calc. And then I'm going to end the lecture with a bit of advice that might be a little, I don't want to say looming, but it's one of those things where I told you might not get a yes or no answer from me, so it'll be a little open-ended. I want you all to, let's see, I want to look at this. If you all want, you can crowd up here. This is fine. I want you all to take a look at this. All right? Now, I'm here in this 2011 guide, and I've got some cost indexing stuff over at the end. Again, this spreadsheet that you see right here is something that I have posted online, so it's nothing that that, that you can't find anywhere else. But I'm on the structural steel framing section, and I've looked at a different section. I'm going to look at a 14 by 74. So if you look over here on the right at a 14 by 74, I want to look at a couple things. So I'm on here, I'm on page 119, and I'm at the W14 by 74. It's near the bottom. And if you notice, I've got a bunch of numbers and data pulled right here, and that data is right here. Everybody see that? So I'm not just making this up. This is where it comes from. So first off, the units are in linear feet, okay? Now daily output, where it says 984, basically what that means, so I wanted you to see where I was getting this data over here on the right. I didn't just make it up. It comes directly from the table. So daily output, 984 is basically 984 linear feet per day that a work crew operating at full efficiency, that's how much they could put out. Labor hours, or they're not referred to as man hours, they're referred to as labor hours in the guide, so just be aware of that. Labor hours per linear foot for this particular element is at 0.057. This just comes from, again, querying contractors who do this stuff all across the country and aggregating their averages each year. Okay, we have material costs, labor costs, equipment costs, total costs, which is just adding these up, and then total costs including overhead and profit. Now, what I want to do is I want to look at a 14 by 74 that's 24 foot long, and I want to look at an overhead rate that's 10%, or I should say, yeah, overhead rate that's 10%. Now, one of the things that you will see that you probably even folks right here sort of missed is there's this sort of arrow that's going down. And if you look in that column, it says crew, okay? And the crew is E2, okay? So if you go farther back in your guide, and I believe you all have crews in that book in the back as well. It should be referenced in the table of contents. But if you look at crews, there'll be crews listed, A14C, AB1, or B1, and C3, and what have you. Crew E2 is essentially a steel worker's crew. It has the cost for a structural steel foreman, 4 steel workers, an equipment operator oiler, and the rental costs for a 90-ton lattice boom crane. So yeah, I wanted to get back to that. So you can see that. So instead of reporting a daily or an hourly cost on the crane, it's reporting a daily cost. So if you needed it, you could take it and just divide by 8. It's considering an 8-hour workday. So does that make sense? Exactly. But what I'm going to do is change the cost estimate around a little bit, and you'll see why. So you can see, we've got bare costs, we've got overhead and profit, we've got costs per labor hour. I'm going to use some of these values, but I'm going to change them up a little bit. So I want to look at this 14 by 74, and I'm going to produce a little bit more of a detailed cost estimate with a tad bit of conservatism in on it. Let me drag that out a little bit. Okay, so what I'm going to do is I'm going to take a look at the 14 by 74, and I'm going to look at its material costs, its labor costs, and its equipment costs. But instead of the labor cost that's listed directly in the 14 by 74, I'm using this $4.58. And let me hit enable editing. And I got that $4.58 by taking the output, basically the output rate for this particular crew, and multiplying it by their hourly cost that includes overhead and profit. So the estimate ends up being a tad more conservative. And I'm doing that because that crew cost includes things like workman's comp, it includes taxes, Social Security, insurance, a lot of that. The cost output in those crew listings is a little more conservative. Now, you'll see on the whole that if I were to just use this $2.70 that's right here, that it really wouldn't drastically change the cost estimate very much. But I figured I wanted to be a little bit conservative. Okay. Excuse me. Okay. I've got here an overhead rate, but I think that should be a profit rate. So we're going to assume a profit rate of 10%, which is very common with very common with this type of work. Students who've done this have projected work with 5% profit rates and 10% profit rates. I'm fully fine if you just say 10%. If you want to do 5 as well, that's fine. But we've got here our base costs, our dollars per linear foot. If we take our dollars per linear foot plus that 10% profit margin, so basically taking each of those numbers and adding an additional 10%, now we've got our rates accounting for that profit. If it's 24 foot long, multiply and add it up. Does that make sense? Everybody okay with that? Yes, sir.
Yeah, what makes us deciding the profit rate? I mean, I know it's typical, but that's what we all work typical 10%.
Yes.
What makes a firm decide 10%, 7, 5?
That's a good question. There's, I'm not going to lie, there's there's a little bit of art to it, but there's a healthy balance between making some profit and producing a competitive bid. If you want to produce a bid where you make 50% profit, go ahead. And guess what? You're going to lose that contract for somebody who's able to produce the work and make a little bit less. Do you see what I mean? There's a balance, is the only way I'll say it. I would also argue that it's very heavily market driven. If your competitors are operating at similar profit rates, it's probably what you're going to operate at as well. That's a good question, though. That makes sense? Anybody else? Yes. I would, absolutely.
How would you like calculate that? Would you put it by a percentage, or would it be like a factor of safety review?
It depends on how you approach your design. For instance, I know that if you have a really, really complicated bridge project, I'm talking really funky connections, really, like cable stay stuff that you don't do every day. A lot of times, if it's that complicated and it needs to be done, I know that there are engineers out there that have just said, we're using grade 50 steel, so I know the yield stress is 50 KSI. You know what? I'm just going to design my connections so that they won't exceed 25 KSI because it's that critical and it's that dangerous and it's that uncertain. So you don't have to go out of your way on your cost estimate side because you're bidding a component that's huge, essentially. Do you see what I mean? But so that's one way of looking at it. Two, if you're a contractor that's just working on a new type of system, a new type of technology, and you know that the material cost is going to be cheap, and you know the production cost is going to be cheap, you might say, you know what, this is new. My construction crew, my folks on the ground, they might not understand what to do, so I might bill more labor hours just to give myself a little bit of cushion. I mean, what you don't want to have happen is promise that you can do the work, with this many labor hours, and then halfway into the project, oh man, we messed up. You don't want that to happen either. So I don't think that there's anything wrong in a scenario like that with bidding a little bit more to give the client assurance that you're taking into account the uncertainty and give yourself some assurance that you can do the job on time. You don't want to be submitting any $30 million change orders in the middle of the project. You want to talk about ticking off a client, and if you're a sub, ticking off your general contractor, that'll do it. Does that make sense? No. Did that answer your question? How about anybody else? Any other ticket items? Okay. I know I'm sort of running out of time, so I want to go through some very general aspects of this. So one of the benefits of looking at it this way by actually, using those item guides, instead of using just this, we could just take 107 and multiply by 24 and be done, and probably get very close to this same number. But the benefit of doing it this way is now we have a material cost, now we have a labor cost, now we have an equipment cost, we have line items. The only other thing that I would suggest that you need to do is this. You have to take that cost, which I pulled out of this guide, the 2011 RS Means Guide, and convert it into $2016. So it did change it a little bit from about $25.80 to about $26.10. And let's also remember I rounded this. This is what I would put in my report or put in my guide. This is what I can hang my hat on. I can't hang my hat on to the nearest penny. See what I mean? So just keep a little bit of realism in what you're producing. Yes?
But if you're doing the calcs, should you include both numbers or just say that?
Let me say this. Let me answer that by saying this. I have no problem with you including all of the specificity and the exactness in your calcs in the background. But when you're standing here in front of a client, don't do that. You can't hang your hat on that, and that's not what you should put in the general summary of the report. In your appendices where you're summarizing your cost calculation, or not summarizing, but you've got your detailed cost calculations. I mean, yeah, you want to show that you were doing the technical computations properly. But that being said, don't submit that penny value as your final answer. You can't hang your hat on that as much as I could. So, does that make sense? Everybody else okay with that? Okay, we'll talk a little bit more about this next time and maybe get into some reporting guidelines and things like that on Friday. But that's all I got. Again, all this stuff is posted online, so unless it don't save. All this stuff is posted online, so if you need to review and whatnot, it's all there. That's all I got, guys. We'll see you on Friday.